Before I went to web platforms, some background programming languages and web development databases, with Python a lot. I like pragmatic functional programming, where it actually gives you real benefit to everyday development and productivity. I care very much about software quality and invested like a lot of thought and a lot of experience in that, and have some experience with automated testing as well, which is a big part of software quality as well, right? So what is Slick? Especially what is Slick compared to ORMs, because ORMs are one of the popular choices out there, right? We often like to call Slick a functional relational mapper, and functional programming and relational databases and relational database queries are rather natural fit. They're much closer than object-oriented imperative programming and relational queries. One big difference is that SQL is a declarative programming language, or declarative language, and so is the functional subset of Scala that Slick exposes. Slick, in that sense, embraces relational, so it really exposes a functional version of relational to Scala users. It's stateless, which makes it, so it doesn't use caching and stuff like this, which is a nice thing. You can ask me about it in the questions later if you want. That makes it nice to use with some things like Play, web frameworks that are stateless as well. And you can say that Slick is to object relational mapping what Scala is to Java. It's a step in one direction. And I structured the talk into two parts. First, I'm going to give you a lot of hands-on examples, like practical reasons. If you use Slick as a library, what you get out of it. And later, we'll take a little step back and look at the bigger picture and see how code generation, a new feature in Slick 2, allows you to basically better support the general idea of modeling data models in your software. So let's get started. Number one of the reasons why you should use Slick, it has a Scala collections like API. So if you know how to use Scala collections, it's rather easy to start using Slick. And well, here we have some hypothetical table device, and usually using Slick you expose it as this object devices, which represents the whole table, and then you can do collections operation on them. You can either use the for comprehension syntax, you can use in Scala as well to describe some transformations of this data, or you can use the method-based syntax with like filter and map. And that's a Scala feature. Scala translates from the upper to the lower. That's not a Slick thing. Slick just uses this. But just with Scala collections, with Slick you have the choices between these two interfaces, and it depends on the case which one is nicer. If you have a lot of joins, then the upper one may be nicer. If you have something very short and inline or something, then the lower one may be nicer. Slick generates rather predictable SQL, at least from the structure. So the collections operations in Scala, they have rather direct correspondence in SQL. And so basically from what you write in Scala, you can predict what the structure of the SQL query is. Slick does some transformations on the SQL code. If you do several maps, for example, it will fuse them, or it will simplify the query in other ways. It doesn't always simplify everything. The compiler, like we could still improve the compiler, and it depends a little bit on your database engine and the optimizer of that engine, how well it will be able to deal with the query generated by Slick. And that's a thing in practice that you will need to take care of. I can talk about that later if someone is interested. But in principle, you are able to predict from the structure of your Scala code what the structure of your SQL code is. Yeah, Slick provides type safety. If you just use SQL strings via JDBC in your program, nobody knows when you made a mistake. Only the database will tell you at runtime. But in Slick, the Scala compiler checks it. So if you have a spelling mistake, or if you've used the wrong type, if you like declare the database column as an int but use it as a string, or If you wrote a query that actually produces something different than you actually wanted, the Scala compiler will see that and will give you an error message. And sometimes these error messages are fine, sometimes they can be rather complicated as well, which is a problem with many of the more advanced Scala libraries, so that's something you'll have to deal with to a certain degree. Sometimes, like in some cases, unless you really know what's going on, you will have to basically look at your code and kind of see what's wrong, which is not so nice, but well, at least it doesn't produce a bug at runtime. And it's a topic we're thinking about improving. There's some well, chances improving that with macros, but we haven't gotten there yet. Another thing that Slick helps you with is basically enforcing consistency between your database schema and the Slick types, because you, or the representation of your schema in your Scala code, because you will need some representation, right? And it may happen that they get out of sync, but what you can do is you can either generate the database, the DDL code that generates the database schema, or you can reverse engineer the database schema and generate the Slick code for that to basically stay in sync more easily. And if you integrate it with your build process or with your general development process, then it's much more feasible to not have inconsistencies. Another thing nice about Slick is that unlike some of the other frameworks out there, there's not like a huge XML configuration or something like this. It's rather simple. One thing you need to do is you need to provide Slicks the types that represent your database table, so the Scala compiler can type check. And this is how you do it in Slick. You extend this table object and this table class, and then you give it a couple of columns, and you can auto-generate that automatically from the database in Slick too. You can also write it by hand. There are some reasons why you might want to do that, which I'll get back to. That's better, I think, yeah. You can, yeah. Okay, can you see the code, or is it?
Yeah.
More.
It's a little... Actually, this is supposed to be pink. I think there's some color missing.
Yeah, it's...
Maybe...
Yes, you pick up on last time.
It's probably maybe up there. So
It's fine.
Okay, cool. So this is... so on the one hand, you need to give Slick the types to be able to type check your queries. On the other hand, at some point you need to connect to a database, and this is the code that does that. You first import from a Slick driver for your database system, or there's also some way to abstract over which particular database you're using. And then you just create a new DB object and a new database object. There's several options. You can either provide a JDBC connection string, or you can use a connection pool and get a data source object and get a Slick database object out of that. And then you can use that to either start a transaction or just start a non-transactional session. And within this block, write some queries. And this, at the end of the block, the session is automatically closed. So the JDBC connection is returned to the pool or just closed. And that's how it works with Slick. And then you can go ahead and write queries. One thing that's also helpful with Slick is you have very explicit control over when database round trips happen, when stuff is executed and what is transferred. Because when you're learning an object relational mapper, a lot of time you spend on actually learning when it executes queries and how you can influence that and basically be efficient in that. Slick is conceptually a Typesafe layer on top of JDBC, and you work with it very similarly, so you're very much in control when stuff happens. Here's a query again, like the one we've seen before, and these queries are just, these operations on the queries, they just build up a query. They don't run the query yet. They just incrementally add operations and add transformations and stuff, and only when you call the .run method, like I do here, then you actually generate SQL code, send it to the database, get the results back. Everything before that is just a lazy building up of the operation you want to do later. And you can also do, like compose the query before, but to run the query you actually need the session. But you can store it in some place where there's no session available. The mapping I showed you before, this table class, it's loosely coupled to what you map to. So there are different options. You can either just use a tuple, so you will get tuples out of queries for your rows. In this case, we made it just a tuple, or you can make it an H-list. Slick comes with an H-list implementation, which allows you to express structural data larger than 22 elements, which is a limitation of Scala tuples. Or you can use a case class. So in this case, we would map complete rows to this device case class. What Slick allows you to do, though, just like SQL, is selecting individual columns. So this only makes sense if you really want the whole database rows, but in many cases it may be more efficient just to select individual columns that are catered to the use case you actually have on your hands. So mapping this to case classes is nice for just very rapidly solving your things, but for efficiency reasons you may want to restrict your queries to just get the things you actually need later. I mean, you can still do that even if you map by default to a case class. You can just restrict to whatever you want to have and return a tuple or something like this. But you don't only have to map to a case class, you can map to whatever you want, because what Slick accepts at this smaller, greater operator is just two functions. One that goes from a database row to any type you want, and one that goes back from that type to a database row. And in this case, this def star equals has a tuple on the right-hand side, so what the function takes is a tuple, but you could equally put an H-list or something else. Only that Slick has to have some knowledge about the type. So Slick comes with so-called shapes, which are basically provide Slick the information how to handle certain types for. So it comes with shapes for tuples and for H-lists, and in principle it's possible to write additional shapes, but it's definitely something more advanced. So you can, it's easier to work based on tuples or based on H-lists and go from there. And this mapping happens after the database results are fetched in the last step. So Slick also provides first-class SQL support, so it's very anticipated that you can write just SQL code, and there are several reasons why you want to do that. One is that not all operations, especially not all supported SQL operations of all databases we support, are implemented in Slick. There are very specific things which don't translate, or some things we just don't support yet, where you can't express that with Slick. There's some extensibility. You can add some operators or some things. There's like a chapter user-defined features in our manual, but sometimes you will have to fall back to SQL, or sometimes the SQL generator of Slick doesn't produce SQL that your database optimizer optimizes well. In that case, you may need to fall back to manually writing SQL as well. And you can easily do that. So you do some imports, and then you define, basically you tell Slick how to get from a database row to whatever you want, and then you can just use our SQL interpolator that allows you to just write SQL and refer to variables in scope. And this SQL prefixed string will automatically escape values you refer to. So it's a very nice way to just write your SQL. One thing that really is a game changer when using Slick is that queries are composable. Basically, you write Scala code against your database. Not all Scala code, not all collections code, just a subset, but it behaves like Scala code. You can write functions, you can write reusable parts, and when you really embrace this, this can really affect the quality of your code structure, because you can suddenly refactor parts of queries and reuse them in multiple places. And in this case, let's look at some examples. So what do we have here? We have this def device locations, and it takes a object, or it takes a value which we call companies, and that's of type query with two type arguments, companies and company. And that's query is a type of Slick, and companies is basically the type that represents the table, and company is the type that represents a single row in the result, and that are the two type arguments the Slick query needs. So this basically represents a query of companies. And what does it return? It returns a query of column of string and string. So column of string is basically a database string, and the other string is the return type. So it does some kind of transformation from companies to basically a collection or a query of strings. And what does it do for that? So it starts with this companies object that is given, and then it goes to the computers, the devices, the sites, and then it maps from the sites to the location. And I'll get to that back in a minute. But that's what's happening. Let's look at the other line. So Apples. Apples filters companies. Companies is an object that represents the whole table. And it filters them by those where the name compares to this %apple % with this I like operator. Okay, so we have some sort of filtered companies, and val locations is a sequence of string. And what happens in val locations, there's this block, and in the block you have device locations, which is the function from the above, right, and takes the apple. So basically we give this filtered companies value to the device locations thing, and we get back a query of strings, right? And then we filter this further. So basically strings need this in America operation, and then we run that, and then we get a sequence of strings back. So a couple of things. Where does this come from? Where does this come from? Oh, and maybe some of you don't know what this is. This basically, if you just put a colon anywhere in your code and write a type, you make an inline type check, basically. You can, in something like Java, you will always write a type in front of a variable name, and then you declare the type of this variable. In Scala, you would optionally write a colon behind the variable name and then write the type. But you can put that anywhere in your code. You can just put colon type to make basically whatever expression you have, just check that that's actually the type, which can help you when you have type inference to understand what's going on. Okay, so let's look at a couple of things. First thing, Slick allows you to reuse queries, right? We have this navigation through the data model graph. We put this in a function. We can reuse it in several places if we need it. So it allows us to refactor parts of our queries. And another thing is, it allows us to reuse joins. So this computers and devices and sites would not be something that comes with Slick. That is something that you could define as a user. You could basically define extension methods on a query of companies using this implicit class concept in Scala and say, okay, so extend my query of companies with a member, computers, and here's how it works. So you would write a query that shows how you get from companies computers to computers, and that's a user supplied thing. Then you could go further. You could write an additional implicit class that adds a method devices to a query of computers, and so on. So you can, and you don't, I mean, this could be just a simple join between a table companies and a table computers, but this could also be a join that spans over several tables or anything. Basically, this allows you to provide whatever association mapping you want. In many frameworks, you would hard code one-to-many or end-to-end relationships. And that's a feature of the framework that specifically supports these use cases. In Slick, there's no specific support for one-to-N or end-to-N. It's just like in SQL, you would write a join that goes over several tables. And the difference is you can place that join in a function and reuse it, and basically this way you can describe your mapping as a query, just like you would in SQL, but you can reuse it. And that way you have you're very flexible in how you can map stuff. And
one question. So
yes.
Devices would be defined on the computers.
So you would write an implicit class that takes a query of computers, and this implicit class has then a method devices. And this devices takes the query of computers and does some join with, yeah. But you can define whatever you want. And like right now we don't, but we're thinking about pre-generating some of those for foreign keys and stuff like this. And it's not too hard to add that yourself. I'll get back to that later. So another thing, you can also just define operators. So Slick doesn't come with I like. I think there's something like this in Postgres, right? But you can also define it yourself for every database. You can define basically an extension method of column of string that that basically converts left-hand side and right-hand side to lowercase and then does an equality comparison. And then you can save it for reusability as a function. I mean, that's how you write Scala code, but you usually don't think this way when you write SQL code or when you write queries. But no, you can do it. And in America it would be something like that. It's basically, I'm assuming, some function that checks if the string given is a city in America. Oh yeah, and again, all of the stuff you did just composes a query. No communication with the database happens until you call .run, and then a single database round trip happens.
Can you, I mean, not in a demo now, but can you, do you have a fish to what is the SQL? Do you see it in logs or anywhere?
It's logged. You have to hook into the Slick loggers for log4j.
Yeah.
You can also just call, instead of .run, you can call .select statement
Okay.
and print it somewhere. Or for inserts and updates, it's an insert statement, I think, an update statement. Yeah. Yes, and in cases where you experience your queries are slow, you will have to do that. You will have to debug in that way, sure. Okay, so that's like very hands-on, slick examples I think you can relate to very easily. Let's take a little step back and get to the second part of this. So software, we're modeling data in our software, right? But what are we actually doing? We're taking like a small part of the world or something fictional, and we kind of put it into code in some way, or into our software, right? And often we call some part of our software the model, but that's not exactly appropriate, because actually what the model actually, like the model is something more like a higher concept, and it shows up in loads of places. The Slick code, for example, the table classes contain the model, the case classes in Scala contain the references to what conceptually is your data model. There are validations, there's a data access object maybe, there's your play code, there may be a REST API, you may serialize the things, then it's database code, maybe your GUI, they all refer to the same conceptual data model, right? And it shows up in many places. There can be the SQL code that creates the table that names all the columns and the types. There is the Slick table, which again names all the columns, actually twice, once for the Scala name and once for the SQL name and the type. There's the case class in the middle, which again, the same thing. There's the play form, very, like, again, structurally similar, and stuff for HTML generation. And why do we have all this repetition? Because there is a repetition of, like, you keep repeating these column names, right? And there are a couple of reasons for that. One is language limitations. For some of the things, you can't abstract over them in Scala. You can't abstract over, okay, if I have a table, then I need one class that has members. Like for a name column, it has a member of type string, and I need another class that has a name member of type column of string or something like this. You can't express that just using plain Scala code. Or sometimes they appear in different languages or different systems. So the data model may appear in the database, it may appear in your Scala code, it may appear somewhere else as well, in the HTML code, for example. Or sometimes we have repetitions like this because it's quite complicated to abstract over some things in the Scala type system, and sometimes you get to the edges of the type system and you're not even sure if it's possible to abstract over it or not. And sometimes it may be practical to avoid this and keep the project simpler in practice. Sometimes there may also be just external reasons, like you have a backend and a front-end team and you want to separate concerns and basically have them work independently, and then you may actually choose to have some repetition but a defined interface between them. But let's look at the cases where we are forced to repeat stuff even though we don't really want to. And I mean, because, I mean, there are problems with repetition, right? First of all, if you do some rapid prototyping or something, it's a bad out-of-the-box experience. If you use Slick with Play, you will have to write your case classes, your Slick tables, the Play forms, and all that stuff. It takes a while. And when you add a new table, you have to do it again. Okay, that's rapid prototyping. I mean, it's also some implementation effort. So that's bad out-of-the-box experience, but it may not matter to larger companies or larger projects. They are willing to take that effort. What matters more to them is a maintenance effort. When they change stuff later, they will have to change all these places. Or inconsistencies. I mean, if you stay in the Scala world, Scala or the Slick logic will push the Scala compiler to check, for example, that your case class actually matches your table class, but it cannot check that against the play form, which is more dynamic, or the HTML code. So these inconsistencies can lead to, these repetitions can lead to inconsistencies. Also, your Scala code may differ from the actual data model in the database. And also this can lead, like let's say you have some column, every table has a column for the creation date, and it's called created at in the database, but then you call it created in your Scala code, and you repeat that everywhere. And at some point you stumble over the bug, and then you fix that table definition in Scala. Then the bug is still in other places. So you don't, like, you may repeat the same mistake in several places as well. So yeah, I mean, we all know that these are things that are not very wanted. So, I mean, we can't, right? But let's try to refactor anyways. What could we do? So, there's this idea of like data model driven stuff, right? You have this data model as a higher concept and somehow derive all these other things from it. But wait, didn't data model driven, wasn't that something that happened like 5 or 10 years ago or even longer, and that kind of failed and everybody hated it, or some people I talked to at least hated it, and was very verbose and hard to manage and stuff? Well, let's look at it again a little bit. So sometimes we've seen these modeling tools where you move stuff and then generate code. I don't think we want to do that, right? We want to write code. So why not use, I mean, the case classes basically describe a lot about our model, right? We could add some additional information to that, maybe some annotations that give us more information. And then we could use the information we can get from the case classes to generate the Slick tables, maybe generate the play forms, generate the database schema. But wait, the database schema, normally we manage the database schema with migrations, right? We tell the database, hey, you have this now, and you get from there to the new state using this transformation. That's not how we work with code. With code, we edit it and save it. So we have like snapshots in time, which we manage using version control systems. That's quite different. And if you work this way, you can't really, you just change it in the editor. You don't know how you got from A to B anymore. Like you can infer some things, like when you add a new member to an entity, you could see that. But for example, if you rename something, is that like an added column and a deleted column, or is that an actual rename? Or let's say one entity disappears and 2 other ones appear. Is that just the one split up? So you said there's some systems that work this way, that you basically write your code and infer migrations, but it's not an automated process. You will have to have some review process that, or in some cases even write the full migrations by hand. But still, it's one way to go. You can do that. Here's another approach. You could just continue writing migrations against your database schema like you do, and then use the database schema as the main source for basically spreading knowledge about your model everywhere else. Because the database schema is the thing you need to migrate because it's attached to actual data. All the code is something you just look at snapshots, and getting from different points in time of the database to these snapshots is something that actually works fully automatically. And that's what Slick allows you to do in Slick 2. It's not something you have to use. You can work with Slick like before. You don't have to, if you don't buy the whole code generation idea, that's perfectly fine. We're not like forcing you to do that. But we're just offering a new way, and also gradually growing way to take some work off your hands if you think that's the right thing for your project. The most simple thing you can do with the Slick code generator is just use the out-of-the-box feature. There's basically this class, source code generator, which has a main method which you can call and it spits out source code. And one way to use it is you register it in your SPT project as a source generator or as a task, and then you just run it to produce source code. And what it does is it generates all the types needed for Slick to type check your queries and to work with the database. And it is possible to do some minimal customizations just for changing how names are mapped or what type some column gets or stuff like that. And what it does, it produces actual source code. It does not use macros. I'll get back to that later why we chose that. So here's the overview of the process. There's the database schema, and Slick uses the JDBC metadata API to get information about it, and then builds this model, like the one we see in the lower left. Then it's fed into the Slick code generator, and the Slick code generator spits out Slick tables and Scala case classes, and some other Slick-related stuff. It does not generate play forms though, but you get already some stuff. And there's a template on GitHub that basically shows you the whole SPT setup and everything. You can just use it as get started. So the next thing, I talked about generating other stuff from the data model as well, right? And the next thing you could do is actually customize what the Slick code generator generates. And you can generate playforms or DAO or GUI or whatever. And for this, you will need a slightly more complicated build. You will basically first compile your customized code generator, then run it to produce source code, and then use this source code by your main project, right? And there's another, it's an activator template actually, as well an SPT project as well that shows you how to do that. I said that we chose to generate textual code actually instead of macros. But macros are already code generation, right? They're compiler-supported code generation. And they are very nice in certain situations, like they are more convenient than textual code generations in situations where, for example, you have a macro that uses a macro that uses a macro that uses a macro, because that would require a multi-stage build. And because you're using macros, the Scala compiler figures out the dependencies and compiles stuff in the right order for you. And also, if you write macros, there is this feature called quasi-codes, which basically allows you to write Scala syntax and transform that into the tree structure that the macros need. And these quasi-codes already provide you very early syntax checking for your Scala code. We don't get these things when we generate textual code. You will, if you put something wrong in your generator, it will spit out wrong code. And then later, but still it's a type checking time of your project, so it will not reach like your production code. So it's not that bad, but it happens a little later, and early feedback is really good, right? So why did we not choose macros? One reason is that currently for the macros, we don't get any preview of the generated code. That all happens in memory of the Scala compiler. But if you generate something wrong, or if you want to debug the generated code, it can be very useful to actually see it. And that you get with textual code generation. And also, when you're using macros, there's still some Scala compiler knowledge required, not a lot, but you will need like something, you will need to be able to distinguish between type names and term names and use their APIs and stuff like that. You get away without that when you just generate text. So what we allow is that you just extend the Slick code generator. And in this case, we the first couple of lines, they just instruct Slick to fetch the model from the database. And of course, we need a connection for that. And then we have the model, and next we feed the model into the code generator, and we kind of have a customized version of the code generator. And you don't need to understand all the details, but right now you can look at it later or in our documentation. But it's basically works very simple. You just override, for example, this method code, and you add some string to it to add to the generated code. And there's like in this code generator, there's some inner classes responsible for table-related stuff or column-related stuff. And that way you can just hook into the code generation and start very simple. You can just start with the out-of-the-box thing and slowly start customizing things and adding to it as it makes sense for your project, and start maybe play around with generating the joins you need or something like this. So I gave a variant of what I'm saying right now at Scala Days, and one thing I showed there was a fully automatic play CRUD app that basically looks at the database and generates all Slick code, the controllers, well, the controllers were abstracted over, and the templates as well, but basically gives you a whole app with like GUIs and everything, just based on the data model, and using the Slick code generator where necessary. Some stuff is possible to abstract over just in Scala, but in some cases you reach the ends of the limits of the Scala type system, and then we use code generation. And that's the URL where you can find the code. Also, the Scala Days videos should be coming out in like 5 weeks or something. So there will be a live demo in there. And what this demo generates is the case classes, the Slick tables, the play forms and validations, play helpers for generating views. It actually generates JavaScript code that represents some part of the model, which at the client, some additional JavaScript code uses to generate form validations on the client. And it also understands, like just this demo, it's an extension of the Slick code generator, right? This demo understands one-to-many, like foreign key relationships, and also it's like when you create a new entity, it offers you a drop-down list of the related entities. And you could push this further, but this just is an example of things you can do. And well, that's basically what I did, and but at what price. So the vanilla app, before I modified it, it's this computer database app, and there's one that comes with Play, and there's a variant of that comes with Play Slick, the Slick plugin for Play. And I started with that because it uses Slick, right? So this is like 1,000 something lines of code, 1,114. And then I changed it, and I ended up with an app that had in the handwritten code 1,148 lines, and a manually, like an extended code generator with an additional 204 lines. And in total, these handwritten lines are like 1,350, and then the code generator would spit out additional like 228 lines. And basically, this with like 250 additional lines, I managed to get all these features in, right? That's not a lot of lines. Like by saving some code here and adding. I mean, lines of code is not everything. It doesn't tell everything, but it's some metric that can tell you something about if shorter programs or smaller code bases tend to be more maintainable than larger ones. Not necessarily, but some metric. Yeah. So as I mentioned to some people before, I started working part-time at this company called Sport 195 in New York a couple of months ago. And one thing I did there is I basically introduced this concept I was talking to you guys now about into their code base. And they run this website, sport195.com. They're a social network for sports. They represent athletes and fans and organizations, and people can follow organizations, and athletes can maintain their pages, and organizations can maintain their pages. And they also basically, they have all the sports data about, especially US, but also about the world. And they're also the provider of this data to other platforms. And what they use internally is a REST API based on Scala, Slick, and Play that feeds their front end. And they have a larger database, and from this database they map 107 tables using Slick. And all those tables together have 1,120 columns. So it's a reasonably large app. And they also share this database with Ruby on Rails. So it's a pretty real-world scenario, right? What I did there, first I migrated them from Slick 1 to Slick 2. And if that's something you're interested in or something, there's a migration guide on the website. There's also an additional slide about that in my Scala Days talk. And then from Slick 2, I basically introduced code generation. And the whole process of getting started with this took about 3 weeks. The first few, getting started in the beginning was just getting the framework set up for this, was like maybe 3 days or something. But then it took like the remaining time to just shift all of their tables over to actually be auto-generated from the and remove the handwritten code that would later be auto-generated. And during this process, I experienced quite a couple of inconsistencies, nothing like super major, but some columns had the wrong types, or very often the nullability was wrong, like there were 109 columns where something was nullable in the database, but not an option in Slick, or the other way around, and this can lead to bugs. Basically, the database can return a null, but then Slick knows null is not an option. So, well, or you can try to write a null, but the database knows it's not nullable. And all those things don't appear anymore if you generate your code, right? Because it's just an automatic process. And we also had a couple of columns which just didn't exist in the database maybe anymore, maybe they existed before. After we were done with this initial migration, for other features to move them into code generation, it took usually like 1 to 3 days or something. And in the end, we do all these things. Of course, the case cases, Slick tables, we generate CRUD operations, which also give us hooks to do stuff before updates and after updates and things like this. We model typed associations, so we know from one table there's a kind of an association to another table. We also have polymorphic associations, where one table stores the idea of another table, but it also stores a field which table it actually means, so it can relate to multiple different tables. And we do serialization and deserialization, and we extended basically the code generator to understand all these concepts, or our model to understand all these concepts, and the generator to assist us with this code. And what happened in this code base was, so this is just relating to the code related to actually the data model and MySQL. There's more code that is unrelated. And within this code, there was like code specific to each of the models, or to each of the tables, which was like 15,000 lines of code, and there's some abstractions shared by a couple of those, like 780, and we also had some macros like 300 lines. In total, it was 16,000 lines. And basically, using code generation, we got this down by 25%. So we got rid of the macros because code generation turned out to be more maintainable for this use case. The handwritten code specific to all the tables got down by, well, roughly 30%. We saved some of the abstraction, and of course the generator and added some more lines of code. And we also, so we started just basically overriding these def code methods and the other ones, and just adding strings. But at some point, that the file got so large, so we factored that out, and we're now using a template engine, Twirl, the Play template engine actually, to have a separate template for our Scala code that just this subclass of code generator just uses. And that also gives us nice syntax highlighting in the editor. We can just use it as Scala code. And I mean, saving 4,000 lines of Scala codes, that's something, right? The generated code is then 37,000 lines of code in our case, actually. And that may sound bad, but in the end, it's very uniform. So if you understand one of the tables, you understand basically all of them. Plus, it's nicely formatted, so the Slick code generator already formats stuff very readable. And it's very easy to do that when you extend it as well. And a lot of the overhead basically comes from supporting very good interoperability between the generated code and handwritten code. I'll get back to that in a minute. And that's the overall thing we ended up with. So database schema managed by SQL migrations, and looked at using JDBC metadata API, and the model is built, and we have some extra classes, this extra metadata I show here, which basically allows us to provide additional information about our model, which we kind of attach to the model that Slick generates. So here's like a computer, something about computers, and we have some extra information. This customized entity, for example, is information that feeds our code generator with information when we want to have a customized subclass. Well, we have some mechanics to allow hooking into some inheritance hierarchy of the generated code, but we don't want to do that every time, because then we would have to write an empty stub for every single table, even though we just want to customize 2 of them. So we have something to do that, and there's some other stuff. I will show the class in a minute. We use both of these, metadata structures actually to, well, feed our customized code generator. And that code generator uses the template I mentioned before. And this spits out all the Scala code and yeah, all the Scala code we need, which we never change by hand. It's maintained automatically by the generator. And then we have, interop with handwritten code. And that's basically our extra metadata. So we have the name of the table, which ties it to the model generated by Slick, and we have some, we provide names here to allow to specify which classes they map to, and we allow to exclude some columns from the database schema, and we allow to inject different default values stored in the database, so we can actually generate Scala code in there, for example, for generating a timestamp or stuff like that locally. Some other stuff, the customization things, some information about associations. And this allows us to basically express a lot of things about our data model, which is then maintained automatically. So, yeah, practical code generation tips, because I think one thing we learned from this whole model-driven era was that it can become very complex if you're not careful. You really have to be careful where to use code generation. Just make sure it really enhances your productivity and doesn't provide you something very complex and hard to manage. And one thing in general is use code generation as a repeatable process. Never change your generated code by hand. Change your generator. Either change your generator or change your database schema if you use that as a source for your generator, or change, have some extra information that drives your code generator. And make it part of your software, evolve it with the software. And only use code generation if you really have to. Because there is some initial cost. You will have to have a slightly more complex build. You will need a slightly more complex architecture when you're thinking about interoperation between generated code and handwritten code, because you will have to kind of cut your code in a way that you can change handwritten code, but still have other stuff auto-generated, right? Keep it simple. Keep it really simple. Because if you generate something you don't really have to generate, you add complexity to it, right? Because you can't change the actual code you look at. You will have to change the generator, and then there's some interaction in there. Really use it when it gives you a real benefit. For example, if there's real repetition, which you can abstract over. Also, don't encode rare edge cases, something all in the model. Handle those by interoperating with handwritten code. Keep your model simple as well. And one very important reason why it makes sense to keep stuff in normal Scala code, apart from just keeping it more simple, is if you keep it in Scala code, you usually can abstract further over it. It's still compatible with Scala's type system and everything. A counterexample are, for example, Scala tuples. They are auto-generated from size 1 to size 22. You can't abstract over them. If you want to do anything with tuples, you have to code generate again. So code generation can be viral, so be careful where to use it. No? Yeah, so when should we use code generation? Usually as a refactoring, when you notice you have to repeat code and you can't abstract over it, refactor it into the code generator. Just like you would refactor it into abstract Scala code. And the usual suspects are either members, because you can't abstract over things like several classes have a member of a certain name with a certain type, but you can't abstract over for all the members in this class do X. You could do stuff like this with reflection, but reflection is very hard to handle as well, and also there's no basically way to look at the result of what happened. So code generation offers one solution to that. Tuples, or sometimes when you basically hit type system limitations, entity members are one instance of that. have excellent interop between your handwritten code and generated code, because otherwise you kind of drawn into generating everything if you can't interoperate well. So, as I said, don't capture all the edge cases. Instead, allow customizing what the code generator does. And then, in this customization, do the hard code the exceptions. And there are many ways to do that. You can have some kind of inheritance relationship between generated code and handwritten code, or you can just have APIs where one calls the other, or you can use Scala type, like you can use type classes to add functionality on top of something else. And it's really something you should care about, otherwise stuff creeps into the code generator and makes it more complex. Yeah, extra metadata, I mentioned that. That's how we do it at Sport 195. We have this, for every table we have a couple of different hierarchies. One for the class representing the row. We have a base class that contains an interface over all the columns, and we have something customized, handwritten, that inherits from the base. And then again, we have something generated that inherits from the handwritten thing, because you can't inherit a constructor in Scala. So sometimes, sometimes limitations in the type system again force us to generate more. Then we have the same for the for the table companion objects, and or for the entity companion objects and for the tables. That's how we do it, but I think it depends on your case. What's the most useful thing and how you structure inheritance hierarchy. And I think probably it became clear already, but don't treat the generator just as an opaque tool. I mean, you can do that if you just use the out-of-the-box features, but if you use it in your software, it's part of your code, right? You refactor stuff into it, so it should be treated as other code where you move refactored things as well. Evolve it alongside with your code, pull stuff out if you don't need it in there anymore, and put it both together in version control. And the Slick code generator really allows you to scale. You can start very easy, just use it out of the box, then start maybe if you want, customize some things using overrides, and then maybe at some point pull stuff out into a separate template to make it more maintainable. Or at some point you could even throw away the whole Slick base class for the code generator and just use simply the model itself and spit out source code. Yeah, I think I mentioned that. So sometimes there's discussion about should you put the generated code into the version control as well or not, because, well, it's maintained automatically, right? So why put it in version control? But one reason is that it makes diffs also more readable, because when you see a change in the code generator and you see the generated code alongside with it and what changed in there, it makes it very concrete what actually was the effect of what you changed in the generator. So it does make your diffs larger, which is a price you pay for having it in there. On the other hand, it makes it also more readable, and it's rather easy to kind of skip over the generated files if you put them all in a folder or something. Also, I think generated code should be rather readable as well. You should care about indentation and things like this, because you will need to debug it, you will need to read it, even though it's generated. So if you put your generated code into the version control system, it also basically checks that when you change your generator, you still have proper indentation and things like this. Also, it will allow you to compile your project without having the database around, which may be nice. Because if you basically depend on generated code, but it isn't there, and you don't have a database, then so there's some reason to put it in version control. Yeah, an alternative could be, instead of putting the generated code in there, because it's a trade-off, right? You could, at least to be able to compile the code without having an actual database instance running, you could just put a SQL file in there or some data structure that represents your data model. So at least you can generate your code from whatever is in your version control. Yeah, if you try that with Slick, some people use different databases for running tests on developer machines and running tests or running the production app, like H2, for example, on a developer machine and MySQL on production. The JDBC drivers did map types differently to between the database types and the Scala types. So currently that produces different code. So if you try this, like you can't use like H2 for generating the code first and then later use it with MySQL. Doesn't. But we'll get there. We're aiming to abstract over these differences. Yeah, make it readable, the generated code. You can even generate some Scala doc, right? You could generate Scala doc for your members that also tell you which database table it maps to and what the properties of this database or database column it maps to and what. So you can actually leverage that. And something you could consider is exposing part of your data model or the schema representing it using a web service. So when you use a front-end, back-end architecture, your front-end can actually reuse this information as well, which is something I did in the demo app. So for example, let's say you have a route /computer/schema, and that gives some JSON representation, which the front-end JavaScript code can consume. So, as a summary for the code generation, you can, it's not, you don't have to use code generation when using Slick. It's just an offer we make with a new version. But it can help you to get rid of boilerplate and provide more automated and more maintainable experiences for your developers. Well, and in my experience, it works rather well, even for a smaller project. And it's not really hard. I mean, you have just a function or an object that generates code, and then you use that in another part of your build. That's rather easy to understand. It's not like it didn't like with the people I worked with, it didn't seem to feel complex to them. Like stuff, more advanced things in the Scala type system are perceived much more complex than this. Yeah, so that's basically what I wanted to talk to about. So I'll be joining Sport 195 in October full time, and if any of you are interested in going to New York, or even we have one guy working from Madrid, I think. So there may be even some chances for Scala development remotely. Yeah, talk to me in general, follow my Twitter for updates on Slick, and I hope I could get you interested in Slick a little bit. And if you have questions, now is the time to ask. Yes?
So you generate code from the database always, not from schemas, not from SQL scripts, right?
Yes.
Always from database.
Yes. But you could use a SQL script to feed an in-memory database, and then use this database to. This way you could.
To generate.
Yeah.
But
Well,
that's something that you said we shouldn't do, right?
Not yet. Slick isn't set up for this. In principle, I think it's a really good idea to basically put the SQL you use to or the database model you use to generate your code into your version control system as well. But the tooling isn't. Yeah.
And, I assume that. Can I help you?
Sure.
This is mostly with SQL. We're talking about SQL support only, right? No SQL stuff like that.
We don't. Slick doesn't have no SQL support at the moment. We have one student in the Google Summer of Code project working on Mongo support, and he had made some progress. So we have basically something like the plain SQL API we had for Slick. We have that for Mongo in a prototype right now, and next he will be looking at that. But I think for Mongo you will have to have the schema somehow separate, because you can't really read it from the database, right? But then again, like in my experience, with the people I talk to, most people, despite having a data store that doesn't really have a schema, they use it mostly with a schema. They don't have it defined in the database, but the way they use it.
You do have a defined JSON that you put there.
Yeah, but you can have one entity that has different JSON than the next entity in the same collection. And that's something that. Yeah, but most people
You rarely do.
Sorry?
You rarely do have that.
Yeah, exactly. Most people don't really.
Never.
So in principle, you do have a schema. You just can't read it from the database, so you would have to provide it separately. Yes.
It's more a design decision personally. So the code generation works from the database into the code.
Yes.
Is there any reason, or what was the thinking behind not doing the opposite, which is quite common maybe on mobile apps or stuff like that?
Basically, so bottom line, you can't, or you cannot do it fully automatically. To change your database, you will need a transformation. You will need to tell the database how to get from the old state to the new state. But when you have code, you only see the old state and the new state. You don't know how you got from A to B. You don't know what is renamed or what is split up or how you refactored things. So if you want to get the database migration out of it, you will need an additional manual process. Or if you just, I mean, some frameworks just require you to, they do use the classes to generate other stuff, but they still require you to write the database migration on the side. But conceptually, that's a repetition, right? Because you do change your database, your data entities in your code, and then you write a migration that does the same change in the database. So there is some logical redundancy between the two.
You could deduce the migration from the two states. So you have two states. Sometimes you can, but most of the time you can deduce, well, there's a new column, so you're adding a column, for example.
It depends.
Because in most cases, your situations are kind of that simple, right? You just want to add the column. In most cases, you don't split tables, right? It's an approach that is possible, and if you're fine with sometimes in the more complicated cases that may be rare, basically doing the other stuff manual, that's definitely one thing you can do. What we chose to do with Slick is go the other way around. Even though we are aiming for basically allowing the other way as well at some point, basically building the model not just from the database but also from handwritten Slick table classes. We're not there yet, but it's on the roadmap somewhere.
In Slick 1, at least, it used to be possible from table definitions to get the DDL create statement. Is it still available? Or
It's still possible the same way, but you only get the create statement. You don't get migrations, right?
Yeah.
I think that anyway, if you have a DBA, you're going to use the automated script anyway. So I think that, I don't know if it's really useful in production systems, all these generated DDLs. So I think it makes a lot of sense in the way you chose. I think it makes a lot more sense. So just make sure that, so you control your database script and then you generate the code, because I think that code is more disposable than the SQL scripts. I think it makes a lot of sense to do things that we do.
I prefer that way, but I know other people work differently, and that works fine for some people as well. Yeah.
Okay. Next Tuesday, we're having a hands-on session with some exercises and so on. Would you suggest for people with zero experience on Slick, or maybe some little background, maybe try one of the templates, or should we aim for some other more basic exercises like getting some queries done and stuff like that?
The templates, like the basic code generation template, could basically save you the step of writing the table descriptions for Slick. So they would be a nice way to get started with queries right away. Like, if we can, let's have a look at the. So this one on the GitHub Slick space, the Slick code gen example is the most simple one.
And it does have source code for basically, basically it has a SQL file here which just contains a schema and some dummy data which is used to feed an in-memory database, and then this in-memory database is used to generate code, and then this code is used to just again work with the same stuff in memory. And at least what you save when you start with this is all the plumbing stuff. You just can't start writing queries right away, because the plumbing stuff is also something that depends on your project later, and that you will have to fumble a little bit to get it optimal for your project, and that just kind of distracts you from the interesting things, I think, when you get started. So maybe this slick cogen example is actually a nice thing to start. And then what you can do here, well, it contains the basic scaffolding for writing slick stuff. There's a database connection to this in-memory database, which is seeded with this SQL script, and there's this slick database object, and then you can use this to open transactions or open sessions to this. And here we use the generated code to describe a join between companies and computers and a query, and then you can just write additional queries here. And just if you want to change the data model you're working with, just add new SQL code to the SQL file and just start working with it here. I guess that's probably the best way to get started.
Then maybe a step back and try to feel the pain of writing all the table definitions by hand, or inspecting the generated code at some point too.
Yeah.
Also,
This gives you, as I said, the better out-of-the-box experience.
Yes, of course. Okay.
Yeah. There's of course a little bit of transfer when you go from an in-memory database to persistent database, and like you will need to do some plumbing there, but that's something I think you worry about later when you really want to put it into production somewhere, right? Yeah.
I have
Yes.
two more practical questions. Maybe it would be the next week talking with you last time. So what make you decide? So one thing I'm interested is seeing how to model inheritance.
Okay.
And another thing is, you said the auto-generated code you can extend by using implicit classes. So you don't override the generated code, modify it, so but you can still extend it and add things like
Sure.
queries or things like this. I would like to see these two things, how to do them.
Yeah. So regarding inheritance, one significant difference between an object relational mapping system and Slick is Slick basically takes the relational model and maps it to very similar concepts in the functional world. And that's also the subset that Slick supports out of Scala. And since there's no inheritance in the relational model, there's also no inheritance support, so to speak, in Slick. Just like there's no explicit one-to-many or end-to-end relationship support. If you want to deal with that, you'll have to write queries that basically handle that for you.
So I would write a query, get a problem out of it, and then...
Yeah, probably the better suggestion would be to not use inheritance, but model it using associations, or like you can think of roles, right? You can have something have several roles. Because this going from the relational model and mapping this to similar concepts in the functional world makes it very smooth. And in object relational mappers, we all have heard of this object relational impedance mismatch that shows up every here and there, and the inheritance is one of the things that causes it. And you can model around that, like you don't really, I mean, unless you want to use Slick to persist an existing data model, you don't really need that. What you can do is you can have interfaces which several of your classes inherit, so you can work with several tables in the same way. And that's also something if you want to customize the code generator, you could feed in the code generator, hey, these tables have the same interface, and this interface then defines has a member created add and has a member updated add or something.
That would be, I would create a trait and then
Yeah.
tell the code generator to add this trait to the.
Yes. The other thing you asked was for the implicit classes,
Yeah,
right?
Implicit classes. I think there's some Scala question.
Yeah. I have a talk that goes about Slick that goes a little more into detail about this. Scala Exchange last year that talks especially about that. I mean, we can just show some code. I mean, I can just open a.
Well, I don't know if it's interesting for everyone, but maybe you could point me there if you want.
Sure, we can take it offline. Do it later.
Maybe it's boring for the rest.
I don't know how many people use. I mean, most people are slowly shifting over from more object-oriented and procedural thinking to using the concepts in Scala, and I think most projects don't really use type classes except for the ones supplied by libraries on a larger scale. So I don't know how familiar people are with this, but I think it's somewhere in the process. Yeah, I can show you in a bit. Yeah. Yeah.